Greetings of the day, dear students, and today in this class we are going to discuss about resistances in series. And by the completion of this video you are going to learn about different resistors connected in series, then what will be the equivalent value of the resistance, okay, and when the different resistors are connected in parallel, and what will be its equivalent resistance, and also the some examples, numerical problems on different resistors connected in series and parallel. Right now let me discuss about the resistances in series. The first basic is, in series connection, when the elements are connected in series, the same amount of current will flow through the resistors. Same amount of current will flow through the resistors, right? Then when we can call the elements are connected in series, for example, if you are having 3 resistors like this, 1, 2, 3, right? If one end of the resistor is connected to the other and the other end to the another one, and so on, if it such a type of connection is made, right, then we can call it as the resistances are connected in series. The resistances are connected in series. I repeat again, when you can say it, the resistances are connected in series, dear students, one end of the resistor, positive, negative, positive, negative, positive, negative. Negative terminal is connected to the positive, and again here this negative to the other positive, and like this, so on. These are arbitrary. We will take positive, negative, like that, right? So during such case, what will be the total resistance? If it is R1 and if it is R2 and if it is R3, when they are connected like this and they are connected to a voltage source V, what will be the total resistance? That is what we have to find. So one basic rule is the same current flows through all the resistors. In series connection, what will be same? Current will be same. Now from Ohm's law, already we have discussed V directly proportional to I, and V equal to Ri. From Ohm's law, what about the voltage across R1? Let the voltage across R1 be V1, voltage across R2 be V2, and voltage across R3 is V3. Now if you observe, see here, voltage across R1 is I1 into R1, and also you apply the KVL to the loop, right? What KVL will say here? The algebraic sum of the voltages in a loop is equal to the 0, I equal to 1 to n, number of elements. In this context, how many elements are there? One voltage source and 3 resistors. Total 4 elements are there, right? Now observe here. Now the total voltage V equal to V1 plus V2 plus V3. V equal to V1 plus V2 plus V3, right? Just substitute in the place of V I into R equivalent from Ohm's law. That is also equal to I into R1 plus I into R2 plus I into R3. Take out I common. Then R equivalent is equal to R1 plus R2 plus R3. Very, very important, dear students. When number of resistors are connected in series, its equivalent will be R1 plus R2 plus so on Rn, where n indicates the number of resistors. Now for example, if all the resistors values are same, if equal resistors are connected, then what happens? R plus R plus R plus so on n times the R. How do you understand that? For example, if 3 ohms and another one is 3 ohms, 3 resistors are connected in series. Now what will be the R equivalent across this A and B? R equivalent will be, how many resistors are there? 3. Each one value is 3. 3 3s are 9 ohms. R equivalent will be 9 ohms, right? Like that you have to understand. Now observe the resistors in parallel. When you can say that they are all in parallel, in parallel connection, the voltage will be same. The voltage will be same across each element. This point is very, very important. In series connection, dear students, what will be same? Current will be same. In parallel connection, what will be same? Voltage will be same across each element. Now here this diagram is same as, this is also equivalent to, say, this point, positive negative is there, R1, R2, both the diagram represent same only. Observe. Here this is the voltage source. Like this the current is entering, the total current I is entering like this. This is R1, R2, R3. This diagram both are same, right? So all these points you can make it join at one point. There is nothing wrong, because here also all these points you can make it as join at one point, because no other elements are there. Just for look wise, to look neatly, you have written in the form of a square. Otherwise this one is same as this one only. Yeah, now observe. Now the current came up to here. It is getting divided into 3 resistors. This is I1, and into I2, into R2 the current flowing is I2. In the resistor 3 R3 the current flowing is I3. Like this you please first divide the currents, and this the total current entering is I. See, observe, all the positive terminals are connected at one end and all the negative terminals are connected at the other end, right? Now the current I1, I2, I3 through the resistors R1, R2 and R3 respectively. Now from KCL, Kirchhoff's current law, what will be the total current from KCL? Algebraic sum of the currents at a node Ik equal to 0, k equal to 1 to n. Kirchhoff's current law. We know that from Kirchhoff's current law, at this node point, if you apply KCL, what are the entering currents? I. What is the leaving current? I1 plus I2 plus I3. Now from Ohm's law, what about I? Current I equal to V divided by R. Current I equal to V divided by R. All the elements are in parallel, so for across all the elements the voltages will be same. Across all the elements the voltages will be same. So V divided by R equivalent equal to V divided by R1 plus V divided by R2 plus V divided by R3. Very, very important. If it is asked in your exam, you have to draw this diagram and you have to indicate the polarities of the voltages, directions of the current and variable names of the resistors and currents. You just simply first apply KCL and you then apply Ohm's law, and then finally you conclude that 1 by R equivalent is equal to 1 divided by R1 plus 1 by R2 plus 1 by R3. Similarly, dear students, if there are n number of resistors, if there are how many? N number of resistors, then 1 divided by R1 plus 1 divided by R2 plus so on 1 divided by Rn. Most of the times in simplifying the circuits or analyzing the problems, all of a sudden in somewhere in the circuit, for example like this, we will come across 2 resistors in parallel. For example, this is 2 ohms and this is 3 ohms. Current came up to here and the current is getting divided into this part and this part. Now these 2 resistors are in parallel. At that time, what you can do is the equivalent resistance will be R1 into R2 divided by R1 plus R2. So this is circuit. You will get, for example, if this is 1 ohm, these 2 resistors are in 2 ohms and 3 ohms are in parallel, and the resultant will be in series. Observe here, if this is 1 ohm, and whatever answer you get, that will be here R equivalent. Now what about this R equivalent, dear students? How many resistors are in parallel to? What is the formula? R1 into R2 divided by R1 plus R2. What are the 2 values? 2 into 3 divided by 2 plus 3, right? It is around 6 divided by 5, right? So it will be how much? 5 ones are 1.2. So here R equivalent will be 1.2 ohms. Like that you have to understand. If you observe in this problem example, not all the resistors are in parallel or not all the resistors are in series. These two are in parallel, right? And its equivalent value is in series with this 1 ohm. Now what will be your total resistance? Observe, R equivalent of the total for total circuit. Now this 1 ohm is in series with 1.2. Why? Because same current is flowing. Observe, right? So this 1 plus 1.2, this is how much? 3.2 ohms. Like this you have to understand, very very important. In this small example, only two resistors are in parallel and its resultant is in series with 1 ohm, and based on that you should tell the final answer. You should not stop doing the problem. Now only this is like this, and these two are parallel. So number of in different possibilities students will do this problem. There are so many chances of committing the mistake, right? Yeah, what I want to say is, dear students, you remember this formula or memorize this formula. This is very very important. Not every time you are taking 1 divided by R equivalent equal to 1 by R1 plus 1 by R2. If you take out LCM R1 R2 and R2 plus R1, and this is equal to the R equivalent. One more common mistake in a hurry while doing the problems, what student will do is directly, for example, if only two resistors are in parallel, he will forget 1 by R equivalent. Instead of that, he will write like this: R equivalent equal to, this is most of the times we observe from the students in labs and records somewhere. What he will do is, right hand side part they will write correctly only. He will write correctly only like this: 1 by 2 plus 1 by 3, like this he will write correctly only, right? And he will do LCM also properly only. 2 3s are 6, 3 times 3 plus 2. What you will get the answer? 5 by 6. And he will think that as R equivalent. What is the mistake he has committed? He forgot on the left hand side to consider it as 1 by R equivalent. On seeing some hundreds of students in the same subject, I am telling these points. So please don't neglect these points. I repeat again, it is 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. If you are following this one, at last you think whatever you got is 1 by R equivalent. To find R equivalent, 1 divided by that answer you have to take. 1 divided by, for looking at the formula, it seems to be simple. That's what I used to tell to my students. Everything looks simple, but while doing the problems only, might be some mistakes are being committed. Might be it is due to hurry okay, yeah, whatever might be the case, please remember 1 by R equivalent equal to. Don't do like this. R equivalent equal to like that. Possibilities are there. Okay, now let me do small problems. Whatever examples I discussed, we will go from a small simple example to the complicated examples, right? Yeah, observe 3 resistors are there: R1, R2, R3, 10 ohm, 20 ohms, 30 ohms. If you observe, all these are in series, same current flows through the circuit. Now what will be the R equivalent? R1 plus R2 plus R3, 10 plus 20 plus 30, that equal to 60 ohms. Very easy. Now 3 resistors are like this, same 10 ohms, 20 ohms, 30 ohms are connected in this manner, in a parallel manner. You are looking into the circuit. You have to look into the circuit like this, because opening is there provided here at this point. Looking into the circuit, the total current came to here, and voltage across R1 will be same as voltage across R2 will be same as voltage across R3. All are in parallel. In parallel connection, what is the formula? This is important. 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent equal to 1 by 10 plus 1 by 20 plus 1 by 30. You take out LCM. 60 is the LCM. 10 in terms of 60, 6 times plus 3 plus 2, you will get 11 by 60. Very very important. It is 1 by R equivalent, but what we want? R equivalent. Therefore R equivalent equal to 60 divided by 11, 5.454 ohms. 454 ohms, right? Very simple problems. Now let me increase the level of difficulty. Dear students, observe across A and B, what will be the equivalent resistance? If you are feeling confused by looking like this drawing is same as A is there, R1, R2, R3, R4. See, this diagram is same as this one only, just I have drawn in a straight manner. AB, this is R1, R2, and this is R3, and this is R4. On looking at this one itself, we can say R3 is parallel to R4, and you will get one answer that will be in series with R1 plus R2. Already R1 and R2 are in series, plus you will get a third term. This equivalent will be in series with R1 and R2, but those two are in parallel. Very, very important. First you simplify this area. R3, R4 are parallel. So what will be the 1 by R34? I am calling that value as R equivalent value as R34, right? 1 by R3 plus 1 by R4. It is simply R4 plus R3. Take LCM, R3, R4, R4 plus R3. But what about R34? R34 means equivalent of these two resistors. Like that you have to understand. Dear students, in this context, R34 indicates equivalent of these two resistors, third resistor and fourth resistor, right? R3 into R4 divided by R3 plus R4. But what are the values given? 3 ohms and 4 ohms. 3 into 4 divided by 3 plus 4. You will get 1.7143. 1.7143. Now very, very important. That equivalent value, this R34 will be in series with the remaining part, R1 and R2. Now see, R equivalent equal to R1 plus R2 plus, this is just now you have found equivalent value of the two resistors. That value you have to write here, right? Yeah, 1.7143. You will get 4.7143. Dear students, what I want to say is, by looking at the circuit itself, you should say easily which two are connected, or which resistors are connected in parallel and which resistors are connected in series. If you have a doubt, you cross check whether the voltages will be same across the element, or if it is a series connection, current will be same. For example, how I can tell that? For example, you see here, if a current came to here, if current is flowing like this current comes up to here, but after coming here it should get divided. Let this one be through I3, and let through this path be some I4. That means, but through R1 and R2 current is same, then these two are in series. Now this I3 flows like this, comes up to this point, and now this I4 flows like this and comes up to this point. But I3 plus I4 is just before entering, that is same as I know. At the last you will get again I only. That means these two combinations are in parallel, observe, and again in series with R1 and R2. For this entire set, entering current is I and leaving current is also I, like that. If you have a doubt, otherwise not required that much. On looking at itself, you can say which two are in the series and which two are in parallel. Now this is one more important problem. See here, dear students, calculate R equivalent across AB. A circuit is given like this. Okay, looking into the circuit, you should tell. So at last I will tell you, this problem can be done in one single step. At the ending of the problem I will tell you. Here these two are R2, R3 are in series. right? That value will be equivalent value is in parallel with R4, R2, R3 are in series. You will solve first these two. R2, 3 is equal to R2 plus R3. Why? Because R2 and R3 are in series. You got 50. Now this 50 will be in parallel to the 40. Now see, this R3, R2, 3 and R4 are parallel. Now you will find its equivalent. 1 divided by R2, 3, 4. I gave the name. 1 by 50 plus 1 by 40 you will get. And you will get that value as 22.23. Now, after simplifying this part, these two are in parallel, and whatever value you get, that will be in series with R1. That is what you have done here. That simplified part value in series with R1. I repeat again, very very important. Like this only, step by step you have to solve the problems. Dear students, these two are in series. These two are in series. And the resultant is parallel to R4. Now these two are parallel. You will simplify that and you will get some value. That value will be in series with R1. Now observe, this R1 and this value, now these two are in series. These two are in series. You will get some value, and that value is parallel to this straight line, 0 ohms. This parallel to 0 ohms, right? Like that. This one problem, if you practice in your notes, it clarifies so many doubts in your mind. But one simple technique is, observe, current came up to here now. After coming current up to here there is a short circuited path. And looking at this itself, we can say whatever current comes over here, it will not flow to that side. The entire current flows through this short circuited path. Why? Because it is short circuited. A strong line, a short circuited line is connected like this. Observe. So this current will be very very high. Entire current flows through this path. In short circuited path, what is 0? R will be 0 ohms. Resistance will be 0 ohms. Looking at this circuit itself, you can tell simply RAB is equal to 0 ohms. But instead of saying that directly, step by step we have solved here, and we have concluded that RAB equal to how much? DS2 0 ohms. Okay students, so far clear? Two and 3 are in series. Resultant parallel to R4. And again that resultant is in series with R1. And that is in parallel to the short circuited path. Okay. So with this we will conclude the resistors connected in different resistors connected in series and parallel. If n number of resistors are connected in series, dear students, it is R1 plus R2 plus R3 plus so on Rn. Keep in mind here it is R equivalent. If n number of resistors are connected in parallel, then 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus so on 1 divided by R1. Keep in mind here it is 1 by R equivalent, right? So in series connection what will be same? Current will be same. In parallel connection what will be same? Voltage across the elements will be same. In the given problems, these two are simple problems. All the three resistors are in series. In this simple problem, all the three resistors are in parallel. Then you can easily do that problems. But in exam, he will give you the problems where the combination of resistors will be, some will be in series and some will be in parallel, and that parallel resultant combination will be in series with the again some series combination or some parallel combination. That thing based upon the given problem we should decide looking at into the circuit, right? Thank you.